let me share just a little whiteboard on here and talk about what we did on Monday. So remember, we're talking about skin, and we walked through the layers of our skin, right? So our top layer is the epidermis. And remember, this is made of a stratified squamous epithelial tissue. Okay? And remember, it does not have a blood supply. And we talked about how in the epidermis, you have different cells and different layers. So the main type of cell in the epidermis are a type called keratinocytes. Remember, these make keratin. And keratin is that really hard, protective, waterproofing protein. Now, there's other cells, right? Like melanocytes that make melanin, Langerhans cells, and Merkel cells. So we do have other cells in there. We also talked about how we have different layers in the epidermis, right? We have 4 or 5 layers, depending on whether our skin is thick, like the soles of our feet, palms of our hand, or whether our skin is thin, like our lips or our eyelids. Just below the epidermis is the dermis. Derma means skin. And remember, there's 2 layers in your dermis, right? We have the papillary layer. This is the top layer that has a good blood supply. It also has those little invaginations, the papillae, that help hold it to the epidermis really well. It's sort of that interlocking area. And then we have the reticular layer, which makes up about 80% of the dermis. It's a much thicker layer. And remember, these are made of different tissues. We have areolar tissue in the papillary layer. This is a great loose connective tissue. It allows white blood cells to patrol the area. And in that reticular layer, we have our dense, irregular connective tissue that has collagen fibers arranged in sort of a hodgepodge, so that we have nice, strong tissue in there that can withstand tension from lots of directions. And then the last layer that we touched on is the hypodermis. Remember, hypo means below. This is made of adipose tissue. And this is there to protect, to insulate, to provide protection. And your textbook classifies it as part of the skin, as a layer in the skin. In reality, other books say epidermis and dermis are the skin. Hypodermis is just subcutaneous fat. It's the fat under the skin, okay? So those are the 3 layers of our skin that we walked through. So I'm gonna close out of here, and let's go back to our PowerPoint. Boy, this camera is really confused, isn't it? It's all over the place. All right. So we left off right here. All right, so our appendages in the skin. And so we have different appendages in the skin that we're going to walk through. We're going to talk about our cutaneous glands, our glands of our skin. We'll talk about hair and hair follicles. We'll also talk about our nails as well. So let's go through each of those. So the first type of gland I'm going to walk you through is something called a sudoriferous gland. And this one might be a little weird. It sounds kind of weird. I always remember sudoriferous, and I think odoriferous. These are our sweat glands. Whoops, that wasn't supposed to happen. Hang on, let me go back. There we go. Oh, sorry. Technology is awesome when it works. Y'all, this is very frustrating. Hang on. There we go. So those are our sweat glands. We have sweat glands pretty much all over the entire surface of our body. We have about 3 million sweat glands on our bodies. And there's two kinds of sweat glands. We have one type called eccrine. Eccrine sweat glands are glands that you would find on your palms, on the soles of your feet, and on your forehead. You have a ton of these. And typically, these are going to be induced to help regulate your body temperature, bring your temperature down, but they can also be induced emotionally. So, you know, think about it. If you have to get up and give a speech in front of people and that makes you nervous, your palms might get a little sweaty. Bottoms of your feet might get a little sweaty. But when you're hot, your forehead a lot of times will get sweaty. Now, one thing I left off right here is, remember, these are merocrine glands. Typically, what we find is merocrine glands are our sweat glands. Remember, these are the type of glands we talked about in chapter 4, where you have a gland, right, with cells in it, a multicellular gland, and those cells produce sweat stored in vesicles, and those vesicles just sort of burst and release the sweat so it can come out onto the surface of the skin. These are very different from holocrine glands, where the whole cell ruptures, right? Now, another kind of sweat gland is an apocrine sweat gland. These are the ones that we find in the axillary region, which armpit, and in the anogenital areas. Y'all can figure that out, right? Anogenital. These are a little different because these not only contain sweat, but they also contain other products like fat. There'll be lipids. There's also going to be proteins in there. And so sweat by itself, there's really not much there that bacteria want to feed on when it's just water and salt. But if you add lipids and proteins, well, then the bacteria on the surface of your skin are like, yeah, and they go to town and they decompose all those extra products, and that is what causes an odor. And so this is that musty body odor smell that people can get. Again, it's coming from the armpits or the anogenital regions. Now, these do not start functioning until we hit puberty. Thank goodness, babies smell good. I love a good baby smell. I don't know how much I would like babies if they smelled like BO. That would be terrible. So these don't start functioning until we start releasing some sex hormones. These are activated in our bodies during pain. So if you get nervous, if something hurts, or during stress. All right, so pain and stress are typically when those are activated. So again, you know, if you've got to give a speech in front of people, you might sweat from your armpits. I call it white coat syndrome. I get really nervous when I go to the doctor. And I mean, I'll tell you this, I probably shouldn't, but when I was pregnant with my son, I would get so nervous. And my OBGYN, you would have to wear those paper gowns, which those are just cruel. Please just give me like a cloth gown. So I'd get this paper gown and I would sweat profusely from everywhere. And I think it was just my pregnancy hormones and my nerves. And I would literally, when I would stand up, it would be like wet toilet paper stuck to my body. I'd have to peel off all this paper gown. My husband went with me every single time and he would help me peel it off from the back of my legs and from my booty. So yeah, these can get activated during stress, times of stress. Now, some other sweat glands that we have, and these are modified glands. We have ceruminous glands. Ceruminous are modified sweat glands. They are found in the ear canal, and they are modified to secrete cerumen, which hopefully you figured out by now, that is earwax. And then we also have mammary glands, right? Mammary glands are modified sweat glands, and they are modified to secrete milk. Now, other than our sweat glands, the other kinds of glands that we have are oil glands. And the term sebaceous literally means, ooh, boy, that's terrible, huh? I think I can, no, I cannot erase that. Can y'all see that? I'll write it again over here. It literally means greasy. So these are our oil glands. And again, remember we talked about how we have merocrine glands and we have holocrine glands. Merocrine glands traditionally are our sweat glands. Holocrine glands are our oil glands. Remember, these look different in that you have a multicellular gland where the cells at the bottom are going through mitosis. And as the cells rise to the surface, they get really big and fill up with product, and then they release their product out through this duct. So we're going to find oil glands pretty much everywhere on the body. Places you don't have oil glands are palms and soles of the feet. Don't have oil glands there because you have to generate friction from those areas. I already cannot open any jars in our house. And so it would be really bad if my palms were oily because it would just be bad. Oil glands are there. They're all over our body because they really help to soften our skin. They make it softer. They keep our skin from getting too dry. When your skin gets dry and cracks, you no longer have this continuous barrier. So the last thing your body wants is for your skin to get too dry and crack. So your oil glands are there to keep your skin nice and soft. And what they secrete is called sebum. That's the oily secretion. So I do have a slide here that just walks you through some of the disorders that are associated with your oil glands. The first one over here on the left is something called cradle cap. Has anybody had a baby with cradle cap?
Yes.
Yes. Was it bad? Bad cradle cap, Andrea?
Yeah, for my second boy it was.
Was it? Did you have to use like a medicated cream?
I did. His came all the way down to like his eyebrow.
Oh no, poor baby.
And his hair fell out.
Oh no. So with cradle cap, so if you don't know what it is, cradle cap is when the oil glands that are on the scalp become overactive and they produce way too much oil. And what you end up with are, and you can kind of see them on here, you end up with these really scaly patches. My son had it a little bit. Andrea, he did not have it as bad as your son, it doesn't sound like. And it is really tempting as I like to pick at things. So like I was really tempted to want to pick these little scabs off, but you can't because it makes it worse. The best thing to do for cradle cap is there is a medicated cream if it's bad enough. I would use one of those really soft baby brushes, and after I gave him a bath, I would kind of massage his head. And then even adding some extra oil on there. So adding a little baby oil. The reason why these glands are overactive, we don't really know. In babies, oil glands should not be overactive. Think about it. Oil glands on your face are not overactive until you hit puberty, right? And you're releasing sex hormones. So in a baby, it's kind of the same concept. They don't have sex hormones yet. They're not being released, so they shouldn't have these overactive glands. Now, you all probably heard that if your skin is dry, your oil glands release more oil. And so the best thing you can do is add a little oil so that they can kind of slow down. They're not releasing as much. What a lot of researchers think is that the reason babies have overactive oil glands is because they still have those maternal hormones circulating through their body. And this is where they're getting the sex hormones from. Usually within 2 to 3 months, those hormones are getting broken down. And a lot of times it'll resolve on its own. It'll get better. Okay. This one over here on the right, this is a sebaceous cyst. So what you are looking at is the back of somebody's earlobe. A sebaceous cyst is basically just a blocked oil duct. So it's not something, it's not like acne, it's not a pimple. You can't pop it and release all of that sebum and the pus that might block up. Instead, this requires surgery. So when you have a sebaceous cyst, they actually have to cut through that cyst, that area. They drain it, and then a lot of times they'll even pack it and let it heal from the inside out. Now, other than our oil glands, we do have a couple of other appendages, accessories to our skin that I want to mention, like hair. So we have hair pretty much all over the surface of our bodies, except there's none on your palms, none on the soles of your feet, and none on your lips. And then also you do not have hair on your nipples or on portions of the external genitalia. So those are the areas where you would not have hair. Everywhere else is fair game, right? Like our face, our arms, our legs. Functions of hair does a lot of things. You know, I mentioned to you already that you do have some nerve endings that wrap around hair follicles, so that when your hair moves, these nerve endings are triggered and they tell your brain, oh, the hair is moving. So this is a great way for your body to be able to identify when it's windy outside or if you get a pest or an insect on you. The hair on your scalp is actually really important. It's actually an extra layer of protection, but it also protects against UV rays. My poor sweet husband is losing his hair. And so, especially with COVID, I've been cutting my son's hair forever because I used to take him to like Great Clips and they would just jack it up every time. So I'd have to come home and fix it anyway. So I used dog shears to cut my son's hair. And my husband at COVID was like, all right, just cut my hair. And so his hair gets cut super short. And I cut his hair really, really short. And then we went to the beach. And I forgot to remind him that with his hair so short, he probably needs to put sunscreen on his scalp. And that poor man, he got so sunburnt on the top of his head because the hair on your scalp guards against UV rays, right? Your eyelashes, these are also really important because they keep things from getting into your eyes. They actually shield your eyes. And your nose hairs, they help to filter particles. I have been seeing on social media, I've been seeing a lot of videos where people are taking like sticks dipped in wax and shoving them up their nose and they're like waxing their nose. Please don't do that. I mean, it looks like it hurts like the dickens. Not only that, number one, but number two, you need your nose hairs. They are really important. They help to filter particles. Nose hairs end up getting coated in mucus. Mucus is sticky. So as you breathe things in, those nose hairs trap particles from getting down into your lungs. That's really important. Please don't wax your nose hairs, especially not right now, not with COVID. Y'all need nose hairs. So what is your hair, right? So we know where it is on the body. What is it? It is basically dead keratinized cells, right? So the cells of your hair are dead. The cells are made and produced by your hair follicles, which are embedded down into the dermis. And in your hair, you will have keratin. Keratin in your hair is harder than what we would find in our skin. So it is tougher, it's more durable than what's in the skin. And your hair is made up of the shaft. This is the part coming out that you can see. And then the root. The root is what is embedded down into the skin. Now, your hair, if we look at it under a microscope, it has 3 concentric layers to it. It has a medulla. I always remember medulla middle. You are going to see that term so often in anatomy. We have a medulla found in the kidney, right? So it's in the middle of the kidney. A lot of our organs have a medulla, which is always going to be in the middle. Okay, so medulla middle, it is the innermost core of your hair. Around that is the cortex, and then wrapped around the very outside is the cuticle. Okay, so I'm going to come back to this. Are you up? Just kidding. Did y'all lose that, or was it just me? Can y'all still see my screen?
Yes, ma'am.
Oh, okay. Well, it went away on the board for some reason. Hang on, let me see if I can get it back. I have no idea what happened. Okay, back on the board. But I don't know what y'all are looking at. You're looking at the sink now. Sorry, this room is brand new, and so there we go. So we have some technical things we got to work out. They want me in here lecturing so that I can be the guinea pig for all of the other installations around the college. So we're the guinea pigs. All right, so if we look at this picture, we are looking at the hair, right? We're looking at a root. And so in yellow, I'm going to just put an arrow on it so you can see it. All those yellow cells right in the middle, that's the medulla. So remember, medulla, middle. This lighter pink, which you can see on both sides, right? This wraps around the medulla. That's called the cortex. And then on the very outside of your hair, you have this really thin layer. It's just one cell layer thick. You can see it in white. That is the cuticle. Okay? So the cuticle is actually responsible for making your hair smooth. There used to be, back when I was growing up, there were Pantene commercials, you know, shampoo commercials that would show hair under a microscope. And it would always show the cuticle layer, where before you used Pantene, the cuticle layer was all like broken and flaky. And then after you used Pantene, the cuticle layer was laying down. It was nice and smooth. So it'll make your hair more shiny if the cuticle layer is laying flat. Now we also have our hair follicle, right? So hang on, there we go. I don't think I like this camera very much. The hair follicle is basically what's embedded down into the skin. And so wrapped around your follicle is something called the root sheath. We say that the root sheath actually comes from the epidermis. So I'm going to show you a picture of this. So if we look here at this image of the skin, right, notice what color the epidermis is. It's kind of brown in color. Now you can see the shaft of the hair here, and then as it moves down into the skin, you can see here is that root down in there. Look at the cells that surround that hair root. Notice how they are also brown in color. That's telling you that basically the cells that surround that hairball are coming from the epidermis. Okay? So we say that the root sheath basically dips down from the epidermis and surrounds the hairball. So that's the deep end of your hair where it kind of gets nice and big and fat. And again, you do have sensory nerve endings that wrap around that root of your hair, wrap around the hair ball. These are the ones that are going to pick up if your hair moves because of wind or pests. All right, and then the types of hair that we have in the body. We have different kinds of hair. We have very fine, pale hair called vellus hair. Vellus hair is that really, really pale hair. It's like blonde. We find it in little kids. Usually you'll find it on the arms of little kids. You can also find it in females, like on our arms. If your arm hair is really, really fine and pale, also the hair on our face, ladies, a lot of times that is also vellus hair. The more coarse hair, like the hair on your head, the hair of your eyebrows, that's called terminal hair. Terminal hair. So this is that more coarse hair that you would find in your eyebrows, your pubic regions, your scalp. Now, hair growth and density. What makes your hair grow faster, right? A lot of women want to know what's going to make my hair thicker and longer faster. There's a whole bunch of things. One might be nutrition. If you are eating really healthy, if you are getting lots of nutrients, then that might cause your hair to grow a little bit faster, especially things like getting enough vitamin E, right? That can really help our hair grow faster. But then also hormones. If you've ever been pregnant, there is nothing like pregnancy hair. Like your hair will grow so fast and it will be thick and luxurious. But obviously, after you've had your baby, one thing I was not prepared for is about 6 weeks after having my son, I would wash my hair and my hair would fall out, literally in clumps. You lose your hair so fast when those hormones start to drop back off. Same thing with nutrition. You know, your hair can grow and be really long and nice and full if you're getting really great nutrients and you're eating really well. If you have a really poor diet, or, you know, women who are not eating enough, if you're not consuming enough calories, then a lot of times you're going to see it. You're going to see it in your skin. You're going to see it in your hair. So getting good nutrition and also those hormones can play a big role on hair growth. Also, the rate of hair growth can be influenced by other things as well, right? So we have nutrition, we have hormones, other things like your sex, your age, right? So males and females, women, because of estrogen, our hair typically grows a little bit faster than a man's hair would grow. But your age can play a big role in that as well. The younger you are, the faster your hair will grow. As you age, your hair gets thinner and it does not grow nearly as quickly. So there's 4 things right there that can really influence hair growth and density: nutrition, hormones, sex, your age. And then the last one, number 5, I saved it for last, I'm going to star it. This one is probably one of the more important ones when we're looking at our bodies, from one body part to another. So, you know, have you ever wondered why your eyebrow hairs are so short? The hair on your head can grow and be really long. This is the same kind of hair, right? It's terminal hair. It's that coarse hair. So why do your eyebrows stay only like, you know, a ½ inch or an inch in length? And the reason is because the follicles that are growing the eyebrow hairs are only active for about 3 months. After 3 months, that follicle will drop the hair and go dormant. Now, all your follicles are not active and dormant at the same time. So it's not like you lose all your eyebrows after 3 months. Instead, you have other follicles that are becoming active when one goes dormant, right? But if they're only active for 3 months, that's the longest you can grow that hair. Whereas the hair on your head, these follicles are active for 10 years at a time. And so for 10 years, you can grow your hair, and then that follicle will shed the hair, it will go dormant, but other follicles might be active. So there's a huge difference in how long the hair can grow, depending on what body part we're looking at. Now, we do have some disorders that can affect our hair. So one of them is called hirsutism. This is excessive hairiness. Now, we don't notice this as much in men because testosterone causes men to have more hair anyway. So this is what's going to cause men to have hair on their chest and on their face. But in women, if women have excessive hairiness, if women have hair on their chest or on their face, we notice it, right? So this is caused by excess androgen production. Androgens, an example of an androgen is testosterone, right? So, you know, ladies, we do produce some testosterone, but if you have an overproduction of it, then you're going to start to see some more male characteristics. Like your voice might be a little lower. You might have hair in the male pattern, like on your chest and on your face. Typically, this can be caused by adrenal gland tumors. Remember, your adrenal glands sit on top of the kidneys. Or it can even be caused by ovarian tumors. So if a woman has this, it's really important that she figure out what is causing this. Another hair disorder is something called alopecia. Alopecia is when the hair, and it can happen in men or women, becomes much thinner. And when I say thinner, this is what your book says, hair thinning. It's not really just hair thinning. You actually cannot grow hair in entire patches on your scalp. I have a old friend whose daughter has alopecia, And she can grow little tufts of hair in places, but she cannot get a full head of hair. And this is a genetic condition. And then the last one is true baldness. True baldness is also a genetic condition. It is typically sex influenced. So we say it's typically X. So I'm not going to go back over genetics and what an X-linked condition is. I'll mention it briefly, so just to jog your memory. So remember that women, our sex chromosomes are XX, and men, their sex chromosomes are XY. So what that means is that if there is a recessive genetic condition, if you see it on one of the X's in a woman, then it's typically not expressed. But if it's carried on the X for the male, since there's only one X, it's going to be expressed. So this is why we typically see it in men. It's carried by females, but it's expressed in males. So this is why a lot of times people might say, you know, to a man, hey, to know if you're going to be bald when you get older, look at your mom's side of the family, because your mom would be the carrier of it. Then she would pass it to her sons, and if her sons get that particular genetic condition attached to their X chromosome, they would express it. Okay? So one type of true baldness is called male pattern baldness. Male pattern baldness, again, it is a genetic condition. It's an X-linked condition. And it actually causes the hair follicles to respond negatively to something called dihydroxytestosterone. DHT, dihydroxytestosterone. Basically, testosterone. So a lot of times, usually we'll start seeing this in men in their early 20s. And what happens is it's truly when they start producing more testosterone. The hair follicle sees the testosterone as something negative. It actually causes the hair follicle to drop the hair. So as long as testosterone is present in the body, the hair follicle will drop the hair. It will not grow or regrow new hair. So there are some drugs, there are some ways that we can relieve male pattern baldness. Drugs that inhibit testosterone production. Now, if you ask a man, hey, you want me to turn off all your testosterone? Let me tell you about the side effects. You're not going to have the same muscle mass, and you're probably not going to have a sex drive. I think most men would go, no thanks, I'll just have no hair. I'll just shave my head. That's fine. Don't worry about it. So taking a drug that inhibits testosterone means that all the things that testosterone normally gives a man, which is the greater muscle mass, the lower voice, the pattern of hair all over the body, they wouldn't have that. And so this one, there's a lot of trade-offs with that particular drug. Another drug is called minoxidil. Now you've probably heard of Rogaine with minoxidil, right? Rogaine is that topical treatment that you put on your hair that helps you regrow your hair. Actually, minoxidil was originally invented as a blood pressure medication. But during clinical trials, people were coming back and reporting their findings, and most men were coming in going, yeah, blood pressure. But look, I have hair. And they actually discovered, hey, you know what? This does a better job at regrowing hair than it does with blood pressure. And so they had to rebrand and remarket this drug as something that could help regrow hair. And then the last one that's on here is finasteride. Finasteride is a pill that you take as a man. You would take this every day. And what the pill does is it actually sort of masks testosterone from the hair follicle. So it makes it so the hair follicle doesn't see the testosterone in your body. You're still making testosterone. It's still in your body, but now your hair follicles don't see it, so they're not going to drop the hair. So this one is very promising, but you got to take it every single day, because if you forget one day, then your hair follicles see the testosterone and you start dropping your hair, right? So this one's kind of hard to remember to take every single day. So we've done glands, we have done hair. The last appendage I'm going to walk you through is nails. So nails are basically scale-like modifications that we find covering the ends of our digits. So the ends of your fingers, ends of your toes. They are modifications of the epidermis. And your nails are really hard. So remember, we've been talking about keratin. You've got keratin in your skin, you have keratin in your hair. You also have keratin in your nails, but it's a harder form of keratin, so it's more protective, right? So the whole point is that you have this nice protective covering at the ends of your fingers, at the ends of your appendages. The parts of the nail that you need to know, this is a very similar image to this is found in the lab manual for this week, right? And so some of the parts and pieces would be like the free edge of your nail. This is the part of your nail that you cut or file. The body of the nail, that's all the part that's sort of pink, that's connected to the tissue, the dermis underneath. The cuticle, right? Ladies, we know what the cuticle is. The lateral nail fold, this is on the edges. So this is where you might get like a hangnail. My son complains of those all the time. They do hurt like the dickens. Then you also have something called the lunule. The lunule is that little white half moon shaped structure at the top of the nail. And so I always remember lunule, and I think lunar, right? Moon, half moon. A few other parts and pieces would be like the root of the nail, okay? And then you can also see the matrix of the nail. So that's all I'm going to mention about nails. Not a ton, just a little bit. So the last thing that I'm going to walk you through in this chapter is a little bit on skin cancer, and then a little bit on burns and tissue repair. So skin cancer, most tumors that we find in people's bodies are benign. So most tumors are benign. It's not anything we have to worry about. It is just a grouping of cells that have grown. They don't metastasize. And that's what benign means. Benign means not cancerous. And they don't metastasize, which means they don't spread. So what causes skin cancer? The majority of the skin cancers that we have, so if it is cancerous, if it is malignant, if it does metastasize, if it does spread, it's typically caused by UV radiation. We know that all forms of radiation damage living tissues, right? And so how do UV rays cause cancer? What's happening here? So we know that the DNA that's in your cells, that's in the nucleus, is the instruction manual. It tells your cells everything they need to know about themselves, including how often to divide, right? Cancer is just uncontrolled cell division. It's when the cells are dividing too fast and you get a big mass, a big ball of cells. That's a tumor, and that can be cancerous. And so when your cells divide too rapidly, that's not a good thing. And so one thing that UV rays can do is, remember, UV rays can get into the DNA and they can cause your DNA to mutate. They can rewrite the instruction manual. And so now your cells can replicate too often, can divide too often. So it can damage the DNA. It can rewrite the instruction manual. The other thing that UV rays can do is they can target, or they do typically target, a very particular gene. And this is a gene called the P53 gene. We have dubbed this one the tumor suppressing gene. So bear with me as I talk about this one. So normally this is a gene that's in every one of your cells. And the job of this gene is literally to slow down cell division. So think of it as sort of like pushing down the cell saying, don't divide too fast. That's the job of this gene. So it's always suppressing cell division. When UV rays damage this gene, they turn it off. And if the gene gets turned off, well, now you don't have anything telling the cell to slow down. Don't divide too fast. Now the cell can do what it wants, and it can divide very quickly. And again, all cancer is uncontrolled cell division. The cells divide too fast. Okay? So both of these things caused by UV rays can lead to uncontrolled cell division. The second one that's listed up here, this P53 gene, is just a little more specific. Now, one thing that we do know is that when you are outside, if you have been in the sun, you did not have on sunscreen, we know that skin cells, when they are damaged by UV rays, your skin cells are pretty amazing. They'll produce a protein called the FAST protein. This is a protein that's going to cause all those cells that have been damaged to commit suicide. So typically it's the cells at the very surface. They're all going to commit suicide, they're going to die, and it's going to reduce the risk of sun-linked skin cancer. Because instead of those cells surviving and mutating too fast, instead they've all died. So this is why a lot of times if you are out in the sun and you get burned really bad, you will peel, right? You'll peel in sheets. That ever happened to you? When your skin just kind of comes off like in big flaky layers? What's happened is those cells have released the FAST protein and they've all died. They've committed suicide because they're trying to protect the underlying tissues. Okay? So there's actually 3 different kinds of skin cancer that I'm going to walk you through. These are kind of the most common forms that we see. So the first one is called basal cell carcinoma. This is the most common. This is also the least malignant, meaning that it doesn't typically spread. Sorry, it's the least, not malignant, the least to metastasize. Doesn't typically spread to other places. We also have squamous cell carcinoma and melanoma. So those are 3 forms of skin cancer. And I have them listed up here from most common to least common. Okay, they're also listed from doesn't metastasize very quickly to metastasizes very quickly. Okay? So let's go through each of these. So we'll start with our basal cell carcinoma. Again, this is one that does not metastasize very quickly, so it doesn't spread very fast. And it is the most common form of skin cancer that we have. This one is actually, the reason we call it basal cell is, hang on. Woo. Sorry, my board's doing something super crazy. I was just listening to a podcast about ghosts. I feel like there's a ghost in here. All right. So the reason we call this one basal cell carcinoma is because it arises from that bottom layer, stratum basale. So what's happening is cells in the stratum basale are dividing uncontrollably. And what's happening is those cells are dividing uncontrollably and they're actually pushing downward, down into the dermis. So they're invading the dermis and the hypodermis. Now this one, like I said, it's slow growing. It does not metastasize very easily. And this one can actually be cured most of the time, 99% of the time, by just doing this sort of wide surgical excision. And this would just be where they sort of cut out the cancer. So they would just sort of cut out this whole region, do a big wide excision, and then stitch it back together. Now, another way that they'll typically do basal cell carcinoma is they can do a type of surgery called Mohs surgery. And it's where they go in, it almost looks like a melon scooper, and they kind of scoop it out and then immediately run pathology on it while you're still there, while you're still in the office. They make sure they got clean borders. What that means is there's no cancer on the edge of what they cut. If there's still cancer around the edge, that means they may have left cancer up here, in which case they will cut out some more. So they'll go deeper and deeper until they get clean borders. Okay? But 99% of the time, they can cure this using that wide surgical excision. Squamous cell carcinoma. Squamous cell carcinoma is a type of cancer that comes from the keratinocytes. So remember, keratinocytes produce keratin. These are the ones that are found in that epidermis, typically coming from the stratum spinosum. These arise most often in places where you get the most UV rays. So your scalp, tops of your ears, your nose, your bottom lip. These are all places where you get a lot of UV, direct UV rays, also places that a lot of times you forget to put sunscreen on. Okay. This one, it grows faster than basal cell, and it will metastasize if it is not removed. And the prognosis is good if you remove it surgically and then a lot of times treat it using radiation. And then the last form of skin cancer, whoops. Y'all, I'm struggling with this camera. The last form of skin cancer is called melanoma. Melanoma is cancer of the melanocytes. That's why it gets it, how it gets its name. This is the most dangerous form of skin cancer because it metastasizes very quickly. So it spreads really quickly. And it is resistant to chemotherapy. So normally how we treat any kind of cancer that has spread is if it's spread throughout the entire body, we're going to give you a treatment that's going to kill off rapidly dividing cells. And that's what chemotherapy does. Chemotherapy is a whole body treatment and it kills off any cell that divides rapidly. Well, now you got to think about it. You actually have cells in your body that naturally divide rapidly, right? Like skin cells. Your skin cells divide rapidly. The lining of your intestines and your stomach, they divide rapidly. You're replacing the lining of your stomach about every 2 to 3 days. So this is why when people have chemotherapy, this is why their skin gets so dry. This is why a lot of times they get nauseous and they throw up. It's because this is a treatment that's killing off all the bad things that are dividing rapidly, but it doesn't know the difference between the bad things and the good things. Naturally, epithelium divides rapidly, right? So it is going to target things like linings and coverings of your body. Unfortunately, this is pretty much the only treatment we have right now for cancer, that it has spread and metastasized. And unfortunately, this doesn't work for melanoma. So if somebody has melanoma that has spread and metastasized, usually they're going to have to do a wide surgical excision. So they're going to have to cut it out from this original area. So they'll excise it and cut it out. But if it's already spread, usually they might do some immunotherapy. That might work, but there's not a whole body treatment that works on melanoma. So this one is incredibly dangerous. So this is why it's really important that if you are out in the sun, if you, like I was a lifeguard when I was younger, I was always a swimmer, I taught swim lessons, I was always outside, and I grew up in the 80s and 90s, we didn't wear sunscreen. That just wasn't a thing. My parents have always had a boat, so we're always on the lake, and I would just get fried on my face. And I pay the price for it now. You know, I go to the dermatologist 3 times a year because they've removed things from me that indicate that I am more at risk for melanoma than somebody else. So I'm going for mole checks 3 times a year. It's quick, it's painless. All I do is just kind of scan you and look for anything abnormal. You know, if you are in your 20s or older, I would say that you definitely need to be going for mole checks. Some of these things are really deadly. Let me see if I can erase this. Hang on, give me just a second. It's going to drive me bonkers. Nope. Okay. Well, we're just going to have those black lines on there. I can't get rid of them. One of the things that a doctor will do if they're doing a check on you, or something you can do on yourself, is you can do a screen. And so what they're looking for, when I go into the doctor, when I go to my dermatologist, she looks for anything that looks abnormal, and they follow what's called the ABCD rule. A stands for asymmetry. So if the 2 sides of the pigmented area don't match. So maybe you have a mole that on one side it's nice and round, and on the other side it looks more like that. That is a red flag. Border. The border is irregular. So if instead of being nice and round, it does this, right? It should look like this. So if you have a mole or a freckle that is a little irregular, that would be the border. Color. If it is black, brown, tan, mottled, so a mixture of all of those, or has any red or blue in it, you need to have it checked. And D stands for diameter. If it's larger than about 6 millimeters, which truly is only the size of a pencil eraser, you need to have it checked, okay? Now, the last thing I'm going to walk you through in this chapter is just a little bit on burns. So 1st degree, 2nd degree, and 3rd degree burns. These are actually named for the layer of skin that has been damaged. So a 1st degree burn damages only the first layer, the epidermis. And what you're going to see in a 1st degree burn is the epidermis has gotten damaged, your skin is very red, and it might be sore. It might hurt to touch it. So an example of a 1st degree burn would be like a sunburn. A 2nd degree burn damages 2 layers of your skin. It damages the epidermis and upper regions of the dermis. So what you're going to find in terms of symptoms of a 2nd degree burn is you'll have redness. It'll be painful, but it's usually also accompanied by a blister. So remember, I told you earlier in this chapter, what causes blisters is when the epidermis and dermis pull apart from each other. You get a fluid-filled pocket in there. And that can be from friction. It can also be from a 2nd degree burn, right? You damage those 2 layers, they pulled apart, and now you get fluid. So examples of a 2nd degree burn would be like an oven burn, right? You're pulling cookies out of the oven and you accidentally hit the side of the oven with your hand. You might get a blister in that area. Curling iron burns, right? Or flat iron burns. Get them on your neck. Sometimes those would be 2nd degree if you get a blister. And then a 3rd degree burn. This is where you've damaged all 3 layers of your skin. Now, a lot of times with a 3rd degree burn, it'll look different. It just depends on the person. Sometimes it is bright red. Sometimes it's sort of charred looking, black. Sometimes it's white in color. But initially there is no swelling or pain. There is no pain because you have damaged every nerve ending that's in your skin. So you don't feel anything. Now, as your body tries to heal and as those nerves try to regenerate, you're going to feel it, and it's going to be very painful. A lot of times, skin grafting is necessary if the area is big enough, meaning they'll have to take skin from somewhere else on your body to sort of help heal that area that's been damaged. The biggest issue with a third-degree burn is typically fluid loss. Think about your skin. Your skin is a waterproof coating. It's your body raincoat, right? It keeps the inside in and the outside out. So if you've burned through all 3 layers of your skin, you don't have that waterproof coating anymore. So fluid loss is a huge problem for people with third-degree burns. So this is actually an image. This is from a former student of mine. She gave me these pictures, told me it was fine to include them in lectures. So this woman was a manager at a fast food restaurant, and she was closing the restaurant down for the evening, and another worker with her, they were cleaning, and she was up on a ladder doing something, and the other worker was cleaning the fryer vats and had taken the fryer vat out and set it on the floor. Well, this girl did not know that the fryer vat was right behind her. And as she came down off the ladder, she put her foot into that burning oil. And so you can see in the image, you can see that her skin is cherry red. Now you can see the bottom of her foot. So remember, this is all thick skin on the bottom of her foot. So that skin actually did sort of okay. They had to do a skin graft. They took skin from her thigh. You can see where they grafted it right here on her. And so this is 5 weeks after her skin graft and a wound vac for healing over here on the left. So you can see that, you know, it takes a long time to heal from this. And then you can see on the right, that's 8 weeks after surgery. And so that burn of hers would have been classified as a critical burn. And the reason is we use something called the rule of 9s. The rule of 9s is how we estimate whether a burn is critical or not, how severe it is. What we do is we divide the body into 11 areas. Each one is 9%. That's why it's the rule of 9s, right? 11 times 9% is 99%. The other 1% is coming from the perineal region. So this is that anogenital area. A burn is critical if over 25% of the body has a second-degree burn, if over 10% of the body has a third-degree burn, or if there are third-degree burns on the face, the hands, or the feet. So you can see her burn was classified as a critical burn since it was on her feet. So this is showing you the rule of 9s, right? So you can see the body and how it's been divided up. You can see this is just an anterior view. So you've got the front of the head, right, is 4.5%, and the back is 4.5%. So your entire head is 9%. Your arms, again, the front is 4.5%, the back is 4.5%. So one arm is 9%, the other whole arm is 9%. Now the legs are going to count for more, right? So the front of each leg is 9%, basically 4.5% for the thigh, 4.5% for down in the tibial region. So the full front of the leg is 9%, full back of the leg is 9%. Anterior trunk is 18%, and the back is 18%. Okay, so all of that will add up to 100%. All right, so the very last part of this chapter is just on tissue repair. So if you damage your skin, you get a cut, how does your body go about repairing that? Well, you can heal your damage one of two ways. One is through a process called regeneration. This is where you replace what's been damaged with the exact same tissue. So later on, you never even know it was damaged. So it would be like, you know, you get a scratch, maybe your cat scratches you. Your body will replace that with the same tissue, and you're not going to be left with a scar or anything. You wouldn't even know. You wouldn't know, you know, 2 weeks from now that you had anything wrong. The other process is through fibrosis. This is when the damage is pretty severe and your body can't replace it. It's too much. You can't replace it with the same tissue. Instead, you replace it with scar tissue. Which type depends on the severity of the tissue damage, right? If it's really severe tissue damage, you're going to replace it with scar tissue. So the steps that we have for fixing damage, a cut in your skin, for example, would be inflammation, organization, and regeneration. So let's go through each of these steps and talk about what they mean. So inflammation. So you can see over here the skin, you've gotten a cut in your skin. First thing that's going to happen is the whole area is going to get inflamed. This is actually part of the immune response. So this is a normal phenomenon. What happens during inflammation is your blood vessels dilate in that area. They get big and they pump blood to the area. So it gets red, it gets hot, it gets swollen. And you're not only pumping blood to the area and fluid to the area, but you're pumping white blood cells to the area. And they're getting there so they can fight the infection, okay? So you're releasing a lot of chemicals in this area so that you can call for increase in blood flow, that you can get these white blood cells in the area. You also have some clotting factors that come to the area. Clotting factors help your blood clot. And so these clotting factors are going to help to stop blood loss. And that's really important, right? You get a cut in your skin, you're going to bleed, but you don't want to bleed for too long. Bleeding is important because it actually helps to flush the wound out. But if you don't stop bleeding, that's not a good thing, right? You would lose too much fluid. So eventually you want clotting factors to stop the blood loss. And those clotting factors are also going to help you create a scab. Scab is your body's temporary Band-Aid so that you can quickly seal over that wound and make that skin, that barrier, continuous again until it heals. It also prevents those microbes from coming in. The second step is called organization. And again, this is where you start to replace the blood clot with granulation tissue. Granulation tissue is sort of like a scab. Now we know that granulation tissue has a lot of capillaries in it. You know this. If you get a scab, if you have a scab, my son does this all the time. His knees are covered in scabs. And he'll sit on the couch and pick at his scabs. And then guess what? They bleed all over my couch. So we know that scabs and granulation tissue, they have a lot of capillaries. And the capillaries are bringing the blood flow. They're bringing white blood cells to help fight infections. They're also bringing fibroblasts. That should sound familiar. Remember, fibroblasts are the type of cell that makes connective tissue proper. And so fibroblasts, since they make connective tissue proper, like areolar tissue, this is what we have in the papillary layer of our dermis. Dense irregular tissue, that's what we have down in that reticular layer. Since these fibroblasts help to make that tissue, they're going to help to rebuild the tissue. They're also going to help make collagen fibers. Remember, collagen fibers are stronger than steel. So these fibers are going to span the wound, right? So, can you erase that? Nope. They're going to span the wound, and they're going to help to pull it together like a zipper. Okay? Also, granulation tissue has bactericides in it. Remember, we talked about how your skin releases bactericidal substances. Granulation tissue does the same thing. And then the very last step is regeneration. Regeneration means that you're going to regenerate that surface epithelium underneath that scab. You may see a scar if you had to go through fibrosis, if you had to replace that with some kind of scar tissue. Okay, so it might be visible or invisible. A scar might be visible or invisible. It just depends on the severity of the wound. How bad was it? Okay, can we see a scar or not? Can you see that scar tissue or not? Last couple things in this chapter are just on the development of your skin. So from adolescence into adulthood, remember when you hit, usually there's not a lot of issues with your skin until you hit puberty. Once you hit puberty, you start releasing sex hormones, and your skin, your hair, they get oilier. So acne can be a problem. Your skin will start to show the effects of environmental assaults around the time you hit 30. So at 30, if you've been out in the sun with no sunscreen, you're going to start to have pigmentation in your skin. You'll start to see wrinkles. Scaling and dermatitis are more common as you age as well. So this is typically common as you get much older. Your skin will get really dry, right? So into old age, a lot of times epidermal replacement of your cells slows way down. So your skin actually starts to get thinner as you age. Have you ever noticed, if you have a grandparent, you ever notice how like you might see bruises all over them? And you'll be like, Nana, what happened to your arm? And she'll say, I don't know, because she really doesn't. Like she could have just bumped into something and you'll see a bruise because her skin is so thin. Epidermal replacement slows way down. The skin gets much more dry, so it's itchy. So I know my mom's always putting on cream. Subcutaneous fat, so that's the fat in your hypodermis, will start to diminish. And so a lot of times you're cold all the time as you get older. I know my husband's grandpa, he lived to be like 98. And we go to the beach with my husband's family every year. And when he was still going to the beach, we'd be out on the beach, Myrtle Beach in July. So it's like 108 degrees. And Grandpa Adams would be out on the balcony with pants and a shirt and a sweater vest and an Afghan over him because he's freezing. So that's really common. You also lose elasticity in your skin, so it doesn't bounce back as well, so wrinkles are more common. And then also you stop producing a lot of melanocytes. Remember, melanocytes make melanin. Melanin protects against UV rays. If you have less melanocytes, you have less melanin. So as you age, you are less protected from UV rays. So it is really important to make sure you're using sunscreen. Okay, so that is it for chapter 5. Does anybody have any questions from chapter 5?